Human evolution reached a turning point when imagined threats gained the ability to activate the same biological machinery that responds to real ones. For most of our species' history, fear was calibrated to external events, lightning bursts above 120 decibels, predator acceleration patterns, shifts in atmospheric pressure and acoustic anomalies that indicated approaching storms. But once the brain evolved the capacity to run detailed internal simulations, the boundary between sensing and imagining began to collapse. Neurocognitive data reveals how deep this collapse goes. When humans simulate being chased, trapped, or watched, between 60 and 70% of the real threat neural network activates. The amygdala responds within 120 to 150 milliseconds. The anterior cingulate cortex elevates conflict monitoring by nearly 40%. Cortisol increases by 20 to 30% even when no danger exists. Heart rate variability contracts into the same pattern recorded during genuine threat exposure. In biological terms, imagination becomes indistinguishable from evidence. Archaeology captures the behavioral consequences with unusual clarity. Occupation layers at Sibidu dated between 58 and 54,000 years ago show rapid and repeated changes in hearth placement, task zoning and sleeping areas during periods of complete environmental stability. Speleothem isotope curves show no storm intensification. Sediment analyses reveal no flooding or structural collapse. Resource indicators remain constant. Yet spatial reorganization occurs again and again. Similar anomalies appear at Pork Epoch and in Levantine Middle Paleolithic sites. These shifts mirror behavioral patterns observed in modern humans under false active threat states, where internal simulation dictates external movement. Environmental settings intensified the disconnect between perception and simulation. Acoustic tests in deep cave chambers show resonance peaks between 110 and 190 Hz, a range that increases perceived motion and elevates amygdala activation even during controlled experiments. Firelight creates luminance fluctuations of 15 to 25% per second, a range known to heighten false detections of agency. In such sensory conditions, the brain encounters incomplete information. Predictive systems fill the gaps with internally generated agents, and the threat detection network responds accordingly. The evolutionary implications are profound. Once imagination could trigger real physiological responses, the nervous system gained a second source of danger. External threats were no longer the sole drivers of vigilance. The brain itself became a generator of risk. This shifted behavior away from purely environmental prediction toward an internal world that demanded management and control. This is the cognitive break that transformed human psychology. Early humans began responding to threats that did not exist outside their minds. Internal simulations acquired the power to redirect movement, reorganize space, and shape collective behavior. From this moment forward, humans had to confront not only the volatility of the world, but the volatility created by their own capacity to imagine. Once imagination gained the power to activate real threat circuitry, early humans no longer experienced fear only during external events. The nervous system began carrying traces of simulated danger long after each simulation had ended. Over time, these traces accumulated and reshaped the body's baseline physiology. Anxiety emerged not from a single imagined threat, but from the persistence of internal predictions that the environment could not resolve. This shift transformed fear from an episodic reaction into a continuous biological state. Neuroscience provides a detailed picture of how this state forms. When imagined scenarios repeat, regulatory structures in the medial prefrontal cortex and insula adjust the thresholds for detecting uncertainty. Instead of reacting only when a threat appears, the nervous system begins monitoring continuously for incomplete information. This produces a measurable change in neural tone. Resting activity in the amygdala increases. The insula heightens interoceptive sensitivity, making small internal fluctuations feel significant. The sympathetic nervous system maintains low-grade activation. Resting cortisol remains elevated beyond typical homeostatic levels by 15 to 25%. Breathing shifts toward shorter, anticipatory cycles. The body no longer waits for danger. It assumes danger is possible at any moment. Memory consolidation deepens this shift. Studies show that after 5 to 7 repetitions of the same imagined threat, the hippocampus stores the scenario in the same systems used for real events. Once encoded, these internal templates activate automatically whenever uncertainty rises. This gives imagined threats the same behavioral weight as lived experience. The nervous system is no longer distinguishing between a memory of something that happened and a simulation of something that never occurred. The archaeological record mirrors these physiological transformations. During periods with stable climate profiles, occupation layers show spatial compression that does not match environmental pressure. At Sibidu, hearths move deeper into protected areas, at times when isotope curves show no storm intensification. At Pork Epoch, activity zones cluster inward during layers where pollen data indicates ecological stability. These contraction patterns are consistent with behavioral ecologists' findings that elevated anticipatory anxiety reduces exploratory behavior by 20 to 30%. Groups behave as though vulnerability is higher even when danger is absent. Internal anxiety also shifts risk distribution inside shelters. Fine napping stations migrate toward darker, acoustically stable zones where sensory ambiguity is lower. Resting areas cluster together, reducing perimeter exposure. Zones with high illumination variation become abandoned. These reorganizations reflect attempts to manage uncertainty generated inside the mind by imposing external stability on the environment. Cognitive attention also transforms under persistent internal threat. Psychophysical experiments show that individuals in high anticipatory states exhibit a 20 to 40% increase in false positive threat detection. Ambiguous shadows, minor echoes, and subtle movements of firelight become signals with elevated salience. In ancestral environments, these false positives were not simply perceptual errors. They triggered real physiological responses and reorganized group behavior. Humans began perceiving possibility as probability. This internal state also altered social dynamics. Groups experiencing persistent internal vigilance adopted narrower decision thresholds. Movement became more conservative. Task rotation slowed. Individuals with heightened sensitivity to uncertainty exerted disproportionate influence over collective decisions because their reactions signaled potential danger. Anxiety shifted from a private experience to a shared behavioral regulator. By reshaping baseline physiology, memory architecture, spatial strategy, and social coordination, internal anxiety created a new layer of selective pressure. Humans who adapted to this state survived not because they responded better to external threats, but because they developed mechanisms to manage the predictions produced by their own minds. And once anxiety became persistent, the next transformation was inevitable. Internal signals no longer simply altered readiness. They began dictating action. This marks the threshold where humans first attempted to control their own imagination through behavior, setting the stage for the emergence of structured responses that would later take the form of ritual. As internal anxiety solidified into a persistent physiological condition, imagined threats no longer remained contained within the mind. They began shaping behavior in ways that archaeology can detect with surprising precision. This marks the moment when internal predictions acquired external consequences. Humans started altering movement, reorganizing space, and changing collective strategies in response to signals that had no origin outside the nervous system. The mechanism behind this transformation is rooted in predictive processing. When the brain encounters uncertainty, it generates internal predictions to fill informational gaps. If these predictions recur, the nervous system begins treating them as data. Once encoded, internal simulations activate motor planning networks in the premotor cortex and basal ganglia. Experimental research shows that after repeated exposure to imagined threat, motor preparation increases by up to 30% even without sensory input. The body prepares to move away, cluster inward, or reorient posture based solely on internally generated signals. Behavior becomes shaped not by events but by expectations. Archaeological layers reveal the first large-scale evidence of this shift. At several Middle Stone Age sites, movement patterns inside shelters change in periods where climate indicators show stability. At Sibidu, activity zones tighten into predictable corridors. Pathways from hearth to processing areas become straighter and exhibit fewer deviations. This reflects a reduction in exploratory micromovements, a behavior known to occur under heightened internal vigilance. At Pork Epoch, task areas cluster into compact units during layers where all environmental signals are normal. These reorganizations indicate that internal predictions were directing movement. Evidence from acoustic mapping strengthens this interpretation. In shelters with strong reverberation patterns, interior layouts shift away from zones where echoes distort spatial perception. These shifts do not correspond to predator activity or weather instability. They correspond to internal attempts to reduce uncertainty by minimizing ambiguous sensory feedback. Humans began arranging their living spaces to regulate the noise produced by their own predictions. Symbolic behaviors offer additional insight. Repeated markings, scrape lines, and clustered pecking traces appear in contexts lacking practical function. Ethnographic parallels and cognitive research suggest that these repetitive actions reduce prediction error by creating stable sensory patterns. Neurological studies show that repetitive motor sequences decrease activity in the anterior insula, reducing the brain's estimate of uncertainty. In prehistoric contexts, such actions likely served as attempts to stabilize internal models by imposing external regularity. The behavior was not ritual yet, but it was the first form of controlling imagined danger. Group coordination also shifted under the influence of internal predictions. When one individual exhibited heightened sensitivity to ambiguous stimuli, others adjusted their behavior accordingly. Physiological synchrony research shows that heart rate patterns, respiration rhythms, and micromovements align rapidly within groups under shared uncertainty. In prehistoric bands, this synchrony amplified internal signals, giving imagined dangers collective influence. A single false positive could trigger group-level repositioning or movement changes. This dynamic explains why spatial reorganizations appear simultaneously across multiple activity areas within a single layer. Hearth usage patterns demonstrate another sign of internal prediction shaping behavior. During periods with no environmental stress, hearths move closer to central points in the shelter where illumination gradients are most stable. Firelight casts fluctuating shadows that can distort perceived agency. By clustering hearths, early humans reduced shadow complexity. This suggests intentional modulation of visual input to suppress the amplification of internal simulations. Motor inhibition patterns also left archaeological traces. In layers associated with heightened internal vigilance, tool discard diversity declines. Reduction sequences become more conservative and less experimental. Behavioral ecology research shows that internal threat states suppress variability by encouraging low-risk actions. The archaeological record captures this constraint. Humans were limiting behavioral flexibility in response to signals originating from prediction rather than from danger. Perhaps the most striking evidence comes from abrupt relocation events. At several southern African sites, groups abandoned positions without any environmental triggers. No change in resource distribution. No signs of predation. No climatic disturbance. These relocations are consistent with avoidance responses, driven by internal simulations that the environment did not justify. The mind became the source of evacuation signals. Together, these patterns demonstrate a fundamental transition. Humans were no longer responding only to the physical world. They were responding to the behaviors of their own predictive systems. Internal danger signals began shaping movement, space, decision thresholds, and collective coordination. The next adaptation was not cognitive but behavioral. Early humans developed structured, repetitive actions to regain control over an internal world they could not escape. This is the threshold where ritual begins to emerge. Not as belief, not as symbolism, but as a tool for managing the mind's own simulations. As internally generated threat signals began dictating real behavior, early humans faced a problem no organism before them had encountered. Their environment no longer controlled their fear. Their imagination did. Prediction systems that once evolved to interpret storms, predators, and acoustic anomalies were now producing danger independently of the outside world. The nervous system was forced to adapt, not by sharpening perception of the environment, but by inventing ways to stabilize the expanding world inside the mind. Ritual emerged as the first structured attempt to regulate internal prediction error. Ritual did not begin as belief, symbolism, or communication. Its earliest form was behavioral engineering. Repetition, sequencing, and controlled sensory patterns served as tools to suppress uncertainty and reduce the influence of intrusive simulations. Neuroscience shows that repetitive action reduces prediction error by 10 to 15% per cycle through decreased activation in the anterior insula and increased coherence in prefrontal striatal loops. These neural shifts lower the intensity of internal threat signals, creating a brief sense of stability. For early humans in high ambiguity environments, this stability carried survival value. Archaeology provides clear signs of this transition. At multiple Middle Stone Age sites, repeated scraping marks, tapping patterns, and pecking clusters appear in contexts unrelated to tool making or resource extraction. The consistency of these patterns is striking. Identical marking sequences appear across layers separated by hundreds of years. At Pork Epoch, a single bedrock surface contains more than 100 nearly identical scrape trajectories. At Blombos, repeated engravings with controlled line spacing appear in secure stratigraphic contexts. These actions did not produce tools, shelter, or food. They produced regularity. Regularity had cognitive purpose. Under heightened internal vigilance, the brain attempts to minimize uncertainty by controlling sensory input. Structured repetition forces the environment to behave predictably, allowing the nervous system to retune its threat models. Behavioral experiments show that predictable sensory patterns reduce false positive threat detection by up to 30%. Prehistoric humans likely experienced a similar regulatory effect. The earliest non-utilitarian markings represent not communication but attempts to impose order on perceptual fields destabilized by internal simulations. Spatial patterning reinforces this interpretation. In layers associated with heightened internal anxiety, objects such as stones, bones, and pigments appear arranged in repeated configurations that lack functional explanation. At several southern African sites, clusters of ochre pieces exhibit consistent directional alignment. At Kafsa Cave, structured deposits of deer antlers appear in positions that reflect deliberate placement rather than discard. These arrangements represent early forms of external patterning used to create predictable sensory anchors. By fixing objects into stable configurations, humans reduced the cognitive burden imposed by ambiguous internal predictions. Ritualized behavior also emerges in micro-movement patterns. Motion tracking analysis applied to experimental archaeology shows that repetitive sequences stabilize neural oscillations in the beta frequency range, which improves motor control under uncertainty. Archaeological traces of these sequences appear in patterned grooves, rhythmic tapping zones, and smoothed surfaces created through repeated contact. These actions were not decorative. They were engineered to regulate neural states. Group-level behaviors reveal another dimension of early ritual. Under conditions of shared internal threat, individuals began synchronizing repetitive actions. Physiological synchrony research shows that coordinated movement lowers anxiety by aligning heart rate variability and respiration across individuals. In ancestral environments, synchrony amplified the regulatory effect of ritual. When several individuals repeated the same action, the group temporarily reduced collective prediction error. Archaeological evidence of synchronized repetition appears in parallel scrape lines, rhythmic percussion marks, and clustered placement of materials. Crucially, these early rituals emerged before myth, story, or symbolic meaning. They were not performed to communicate with beings or forces. They were performed to control the human predictive system itself. As imagination grew more powerful, structured action became a necessary counterweight. Ritual was the technology that allowed early humans to manage a mind capable of generating its own dangers. This stage marks a second cognitive transition. Internal anxiety produced behavioral modification. Behavioral modification accumulated into patterned action. Patterned action evolved into ritual. And ritual created the framework through which humans would begin attributing agency to unseen forces. The emergence of ritual did not answer imagined threats. It organized them. And once organized, the mind took the next step. It began assigning causes to them. This is where the mythic mind begins to form. Ritual created stability, but it did not eliminate internal uncertainty. Instead, it produced a new psychological environment. As early humans repeated structured actions to control ambiguity, they began focusing more attention on the patterns inside their own minds. Repetition minimized prediction error, but it also intensified awareness of the internal signals driving these actions. Once humans could feel their own threat simulations as distinct forces, the brain sought explanations for them. The next transformation began not in the external world, but in the architecture of interpretation. This is where the mythic mind emerges. Not as storytelling, not as belief, but as a cognitive solution for organizing internally generated threats. The mechanism underlying this shift is rooted in agency detection. The human brain evolved to treat ambiguous movement, irregular sound, or incomplete information as signs of intentional agents. This bias, known in cognitive science as hyperactive agency detection, increases under uncertainty. Experiments show that when sensory information is degraded or unpredictable, false attribution of agency rises by 40 to 60%. In cave environments, firelight produces unstable shadows that alter perception within milliseconds. Acoustic resonance amplifies ambiguous sounds. Under these conditions, the brain begins searching for who, rather than what. Archaeological evidence aligns with this transformation. Figurines, abstract engravings, and structured deposits appear in contexts lacking environmental triggers. At Blombo's cave, engraved ochre pieces with consistent geometric patterning appear during periods of environmental stability. Their precision reflects deliberate cognitive structuring rather than reflexive motor behavior. At Kafsa, deliberate placement of red ochre and antlers appears in layers with no evidence of predation or climatic instability. These gestures indicate the brain was generating explanations for internal states by projecting agency outward. This projection did not begin as belief in external beings. It began as an attempt to model invisible causes for internal events. When internal threat signals intensified without clear external triggers, the brain assigned cause to unseen agents. This solved a computational problem. If the nervous system cannot identify a physical threat, attributing the signal to an invisible agent preserves predictive coherence. It becomes easier to plan, respond, and coordinate if uncertainty is packaged into an entity rather than left unbounded. Memory architecture strengthened this shift. The hippocampus encoded repeated internal simulations as quasi-events. The prefrontal cortex integrated these memories into structured narratives. Over time, imagined threats took on stable characteristics. They acquired form, intention, and behavioral patterns. The earliest mythic figures were not deities. They were explanatory containers built to organize internal predictions that lacked physical origin. Group behavior amplified this mechanism. When individuals shared internal threat states, synchrony increased. Physiological coupling during joint rituals aligned heart rate variability and breathing rhythms. This alignment created shared emotional intensity, and shared intensity required shared explanation. Agency assignment thus moved from individual prediction to group-level interpretation. A threat sensed by one member could rapidly become meaningful to the entire group. This is how mythic patterns propagated without language or symbolic instruction. Archaeology documents the emergence of such shared meaning through repeated structured deposits. In Eastern Africa, clusters of pigment nodules appear in consistent arrangements across multiple layers. In Europe, early figurines such as the Hohlfels form show stylized exaggeration, not tied to utility. These artifacts are cognitive artifacts. They externalize internal models. They stabilize imagined agents by giving them fixed features. They allow internal simulations to become socially visible. Crucially, the mythic mind did not arise because humans believed in invisible forces. It arose because the brain needed structured explanations for internal threats that ritual alone could not resolve. When humans began projecting agency onto the causes of their own anxiety signals, the internal world gained structure. Anxiety became story-like. Threat became intentional. Uncertainty became organized. At this stage of evolution, the mind had created a new category of reality. Internal simulations, once fleeting, turned into enduring agents with stable characteristics. This allowed early humans to coordinate behavior around shared models of unseen forces. Mythic cognition began as a functional adaptation, not a metaphysical one. The next transformation follows naturally from this point. Once imagined agents gained structure, they gained influence. And the inner world, now organized by mythic patterns, began shaping decisions in ways that exceeded immediate survival. As the mythic mind took form, the internal world gained a level of influence unprecedented in evolutionary history. Humans no longer acted only in response to storms, predators, or environmental cycles. They acted in response to agents, patterns, and narratives generated inside the mind. These internal constructs were not illusions. They produced measurable physiological responses, dictated group coordination, and influenced long-term settlement strategies. The brain had created a parallel source of reality, one capable of shaping behavior with the same force as the physical world. The mechanism behind this shift is evident in neural data. Once imagined agents were encoded as structured models. The hippocampus treated them as part of the event memory system. Repeated retrievals strengthened their stability. The medial prefrontal cortex integrated these models into causal frameworks used for planning and evaluation. Functional imaging studies show that when humans engage with imagined entities, activation spreads across networks responsible for social reasoning, conflict prediction, and emotional regulation. The internal world became populated not with abstract thoughts, but with cognitively real actors that triggered social and emotional processing as if they existed in the environment. Archaeological evidence reflects the growing authority of these internal constructs. Structured deposits increase in frequency. Groups place objects in deliberate configurations that persist across multiple layers. At Kafsa, ochre-stained antlers appear in repeated spatial formats. At Pork-Epic, pigment nodules are stored in patterned clusters, rather than scattered distributions. At Ohelfels and Wogelhart, figurines exhibit consistent stylization, suggesting stable conceptual templates, rather than spontaneous creation. These artifacts functioned as anchors for internal models, externalizing imagined agents so they could be shared, remembered, and acted upon collectively. Ritual behaviors also began carrying the weight of obligation. When a repeated action stabilized internal prediction error, groups performed it not because of external necessity, but because the internal world required continuity. This is the earliest form of normative behavior. A sequence performed yesterday created a cognitive demand for repetition tomorrow. Early humans were not obeying deities. They were obeying the predictive frameworks of their own minds. Once internal agents became stable, ritual actions became socially binding. This transition altered the structure of decision-making. Movement choices, resource distribution, and group coordination increasingly accounted for internal expectations rather than empirical observations. Archaeological layers reveal relocations during environmentally stable periods, consistent with decisions driven by internal narratives of danger or obligation. Symbolic artifacts appear in contexts that lack direct survival value, yet they persist across generations, indicating that internal models had become part of the group's long-term strategy. The significance of this shift cannot be overstated. For the first time, humans lived in two worlds simultaneously. One outside the body. One constructed through memory, prediction, and imaginative agency. The second world could influence behavior as strongly as the first. It demanded interpretation, continuity, and preservation. Internal narratives began to extend across lifespans, shaping decisions not only for the present but for imagined futures. At this point, cognition began reaching beyond immediate survival. Internal models required stability across time. Patterns of meaning needed to be carried forward. The mind started generating content that could not remain only in the moment. This is where the next chapter of human evolution begins. A new cognitive need emerges, not to react, not to predict, not to explain, but to preserve. The earliest memory humans tried to carry into the future did not come from the world outside them. It came from the world they were building within. Echoes of Sapiens. If stories like this remind you what it means to be human, subscribe and keep exploring with us.